Right, so we're at the Fraunhoffer Institute at the IFA, at the, what's this, the Science and Technology Forum.
Exactly, yeah.
And what are you doing here?
Yeah.
What do you have?
We're presenting Muted.
Yeah.
Muted is a project, a European funded project.
Yeah.
It stands for multi-user 3D television display. And this is about like a 3D application, 3D TV for multiple users.
Yeah.
So what we can show you here, I mean, it's a project funded by the European Commission. Different partners are involved. Our part in this project is the eye detection algorithm.
Yeah.
We want to detect as many people as possible in a room as big as possible, as fast and as precise as possible.
All right.
What you can see here on the screen, right now, if you look towards the screen, maybe, you can see there is the first face. There is a face-like shape is searched. And in the second phase, it only searches for eyes in this pre-detected area.
So you need all these cameras, or?
Right now we need all these cameras, but that's exactly what we want to find out. How many cameras do we need?
Okay.
What kind of cameras do we need? Where do we place them? And right now you see 6 cameras. That's 3 pairs of cameras.
3 pairs of cameras.
Yeah, and that's 1 pair for the near view and 2 pairs for different far views. Yeah. So our aim is we think about like a detection area of 5 by 5 meters to detect every user in this area.
All right.
Yeah. And
5 by 5 meters.
5 by 5 meters.
Here, around here, out here.
Yeah, but right now we work like 3.5 meters.
3.5 meters.
But it's only the setup. This is not the final setup.
All right. So you would put this over the TV in the room, and how?
Not exactly this. That's exactly what we want to find out. What kind of cameras do we want to use? I'm pretty sure it won't be these.
It won't look like this,
Because right now we have LTV cameras that have a refresh rate 50 Hertz, 720 by 576 pixels.
Yeah.
We want to find out exactly what technology we want to use for that. Our aim is to detect the eye position as precise as possible. So we got a coordinate X, Y, and Z.
X, Y, and Z.
We got to give these coordinates to the partners that are developing the display technology.
All right. And so this is just one part of the technology.
Exactly. Yeah. So the other part is being developed by partners. So the Montfort University in the UK is working on that. Sharp is working on that, and Light Blue Optics and other partners. And we try to give them in real time the coordinates of the eyes of the users in front of the future television.
So because here in IFA there's a few places, I don't remember if it's Philips maybe, that have 3D screens, but you have to be in front, in the middle.
Exactly.
So somehow you would be able to change that, so it changes.
Yeah, that's the thought. We want to develop, or the project wants to develop television, which is autostereoscopic. That means you don't need any glasses to see the 3D
No glasses.
effect. No glasses, plus it will be an adaptive system. So you can move in a certain area around and the system will follow you and gives you the 3D...
in 100 Hertz, or how fast can it follow you?
I cannot tell you anything more
because
about
something is physical behind it, no?
Yeah, there will be a projection of light arrays to your eyes.
Yeah.
That's what I can tell you. When you're in the detection area, when you're outside the detection area, you can still see a 2D image.
2D outside the detection area. That sounds crazy.
Absolutely. But we're working on that. I hope we can maybe present something next year from the display side.
Because I've seen also at the DLP they have this new DLP technology, but you need the glasses.
Yeah.
And but when you've got them on, it looks really cool. There's like boxing in the Wii. You see the. I mean, so the point would be. Whoa. Okay.
Yes, our aim with all our systems is always we want to have intelligent systems that adapt to the user. The user shouldn't wear any glasses to see the 3D effect. We want to change the system so that the user doesn't have to do anything.
Nothing.
Yeah. Like for example, over there we have a technology hand tracking system. It's a very large display which you can control by just one finger. One finger. Yeah. Okay, we'll go there. Okay. I'll go there next.
Go there.
Oh,
you finished now with this?
Yes.
Okay, but thanks. Thanks a lot. So we are still at the Fraunhoffer Institute. And there you are controlling a user interface.
That's right.
With your hand in the air.
That's right. Actually, it's the finger we use as an input media. The finger, the position of the finger is detected by 2 cameras above my hand.
Yeah.
The 2 cameras are integrated in this housing.
Yeah.
And they're looking downwards.
Yeah.
In addition to that, you will find a green line on my wrist.
Yeah.
This is used for positioning the hand correctly.
All right.
So actually the laser line has no function, just then showing the position where if the hand is positioned correctly.
If it's there.
Okay. The cameras detect the position of the fingertip in the end. So the silhouette of my hand is detected, and the algorithm is evaluating the two images of the two cameras, and in the end the fingertip is what I use as my mouse. So if I point into the screen, you can see how the cursor arrow is following the movement of my finger. And in this example installation we have here, you can get touristic information about the central station, for instance. You can call different 3D models of
how do you click?
By simply staying on the buttons.
Staying on it.
So as if I stay longer than 2 seconds on a button, it will be selected.
All right.
If it works.
Yeah.
It's been a long day.
All right.
So we have to make. But
so you just need this, and the green light is compulsory. Or could you have a invisible laser?
You don't need no laser at all. It's just for the user an indicator that he knows where to put his hand.
Just to know.
But the cameras, of course, have a range which they can detect it. If you're outside the detection system wouldn't be able to detect the position. So it helps you to put your hand at the correct position.
In principle, could you just have 2 cameras on the roof of your room and that's it?
That's right. If
and
you
as long as
where the detection area is, because it's your own setup, it's no problem. You don't need any laser light.
Because you need a constrained setup. You cannot have HD cameras filming the whole room.
Of course you can. But,
will it confuse it, or
the whole system becomes more expensive?
Yeah.
You have to have bigger PCs because you have bigger images that have to, the search algorithm has to work on. So of course it could be done with high resolution cameras as well.
But you could just install it over your couch, for example.
You could.
And then then you know where to put your hand.
That's right.
All right.
So again, I can select the 3D model. Now you can have different functions to manipulate the model. This, of course, could be something. The content could be something totally else. You could set up something with at your car dealer. Go to your local BMW dealer and you select the models. You select the color, the wheels, all kinds of stuff.
So the finger actually moves it around. So you can move just your finger a little bit.
Yeah. So
nice.
You can see. Actually, the system detects the position of the fingertip in all 3 directions, so it's a 3D detection system.
Right.
And we use it for our autostereoscopic screens to control 3-dimensional objects. But in this case, we only use 2 axes, of course, so it can be used as a simple mouse.
Are the cameras there?
These cameras detect the position of my eyes.
Of your eyes?
Of my
also?
eyes.
For 3D stuff?
Again, if we point on objects, we build up a line. So it goes from our eye over the fingertip to the object we address by pointing it. So the system detects the position of my eye, the position of my fingertip, and now calculates where am I pointing at.
Whoa, so I should put the camera up at your eyes, please. Could I try and... Is it easy to change user?
Of course.
Like this?
If you stand it
so I put my camera at my eyes. Okay, will that help?
But you shouldn't cover your eyes. So
I shouldn't cover.
It has to be able. You should go a little bit closer.
Oh yeah, I shouldn't cover my eyes.
And your face also.
My face also?
Yes.
All right. So, oops. I don't know.
I could demonstrate the function of the eye tracking system by standing in front of the screen and grow and shrink. Simply by going, I can show you.
Sorry.
So, if the detection works, now I'm a small person.
Yeah.
And now I start to grow.
You grow,
and you see that the arrow is jumping.
Yeah.
So the position of the head is corrected.
All right.
The fingertip position stays as it is.
Okay.
But because I'm a small person or large person, my arrow of view goes downwards or upwards. So the arrow is following the movement as I go down.
All right. Thanks. Thanks a lot.